Form and complete a full two-population hypothesis test for proportions critical value approach. A survey of American adults asked participants to agree or disagree with the statement. Gender equality in this country is better now than it was 50 years ago. The results are shown in the table below. Let P sub 1 be the proportion of males who agree with the statement, and P sub 2 be the proportion of females who agree with the statement. Is there enough evidence at alpha equals 0.05 to conclude that the proportion of males is greater than the proportion of females who agree that gender equality is better now than it was 50 years ago? Work through the test procedure and interpret the results of the hypothesis test. Before we do that, let's refresh ourselves on those 5 steps. First, we'll identify the null and alternative hypothesis. We'll decide on the significance level. We'll compute the test statistic. We'll find the critical value, and then we'll use all of that to interpret the results of the hypothesis test. Let's jump in, identifying the null and alternative hypothesis. Remember that the null hypothesis includes the equality statement, while the alternative hypothesis includes the inequality. That could be greater than, less than, or not equal to. In this particular example, we're looking for a higher proportion of males than females. So that is a greater than sign with the males as the first sample. Proportion of males greater than proportion of females. That's what we're looking at. Therefore, our null hypothesis is P sub 1 equals P sub 2. It's got to have the equality statement, where P sub 1 is the proportion of males, P sub 2, proportion of females. And then our alternative hypothesis is P sub 1 is greater than P sub 2. Let's decide on the significance level. We are given this in the problem, so we know that alpha is 0.05. Now on to the test statistic. It is always important to find the formula first. Understand what pieces you need for the formula. Because this is a two-proportion hypothesis test, we are going to use a z-test statistic. And so we're going to need p hat sub 1, p hat sub 2, as well as our p hat pooled. So remembering what all of these pieces mean. Using the information from the problem, we can find our p hat sub 1, because we know that's the male part, and we're going to take the number of males who agree divided by the sample size. For p hat sub 2, the number of females who agree divided by the sample size. For pooled, we put those together, the males plus females who agree over the total sample size of 400. Now that we have our data, we also know that our sample size for both pieces is 200. We plug those in to the correct pieces. We end up with 0.81 minus 0.74 with our square root in the denominator. Very, very important to make sure when you plug this into your calculator, you're using parentheses to follow the correct order of operations. It makes a difference. So we end up with our test statistic of 1.68. Remembering when using the critical value approach, we're going to compare that test statistic to the critical value in order to draw our conclusion and make our interpretation. So to find the critical value, this is a right-tailed test because of that greater than sign. So we know there's only going to be one positive critical value. And population proportions use z-scores. So an alpha of 0.05, right-tailed test, we know our critical value is going to be 1.645. So now when I'm comparing these, in this example, the test statistic, 1.68, falls to the right of our critical value, which means it falls in the rejection region. So because the test statistic is greater than the critical value, we reject the null hypothesis. Therefore, at the 5% significance level, the data provides strong evidence to show the proportion of males is greater than the proportion of females who agree with the statement, gender equality is better now than it was 50 years ago.